Allah the Merciful, the Beneficent, we will complete teaching Unit 2, Lesson 3, which is talking about nuclear energy and radioactivity. In this lesson, I am going to give you all the essential information and tips to understand what's meant by radioactivity and what's meant by nuclear energy. You have known previously that all elements consist of atoms, and each atom consists of nucleus surrounded by electrons, as shown in this figure. Any atom consists of nucleus and electrons surrounded by electrons. So, each atom consists of nucleus surrounded by electrons revolving around it in certain energy levels. And the mass of the atom is concentrated inside the nucleus. Why? Do you know? Because the nucleus contains positive charges of protons and neutral charges of neutrons. So, the mass concentrated in the nucleus. The composition of the atom also is responsible for physical and chemical properties of the element, where chemical reactions between the atoms occur through their outermost electrons, while nuclear reaction occur due to the change in the number of protons and neutrons inside the nucleus. So, let us understand what's meant by radioactivity.
What actually is radioactivity? Many of us have heard this word before, but what does it actually mean? The word is made up of two Latin words, namely radius, which means ray, and activus, which means activity. So it's radiation activity. Thus, radioactivity is the characteristic behavior of unstable cores of atoms spontaneously decaying into different nuclei and emitting radiation in the process. There are different types of atoms with unstable cores, and these are collectively referred to as radionuclides. This gentleman here is Antoine-Henri Becquerel, and he was the first to observe this phenomenon in 1896. 2 years later, it was Marie and Pierre Curie who first used the word radioactivity for this radiation that is caused by the decay of nuclei. But why do these nuclei decay at all? The cores of atoms consist of protons, these are positively charged particles, and neutrons, which are neutral particles. With stable nuclei, there is a certain stable proportion of protons and neutrons. But if there are too many or too few neutrons compared with the number of protons, this equilibrium in the core of the atom gets out of balance, and the core becomes unstable and decays. By the way, there are more than 3,000 different radionuclides known to this day. These can be described by different properties or be divided into different groups of types. One example of this is their classification by the kind of radiation they emit upon decay. In this case, one speaks, for example, of alpha, beta, and gamma emitters. But there is also another property that can be used for dividing up radionuclides.
As we have seen in the previous video, French scientist Henri Becquerel discovered the emission of unseen rays from the uranium element that has capacity to penetrate through solid objects. So, what are radioactive elements? There are two types of elements. It may be stable or normal and radioactive element. The difference between them is normal element have a small number of neutrons inside its nucleus, but radioactive elements has large number of neutrons inside its nucleus. So this large number will have much energy, so it needs to lose some of this energy to become stable. So radioactive elements, they are elements whose atoms and nuclei contain large number of neutrons. This number more than the number required for its stability. For example, radium, uranium, cesium, selenium, polonium, zirconium, and rubidium. After that, There are two types of radioactivity. It may be natural radioactivity. It is the radiation produced from the radioactive element present in nature. But artificial radioactivity, it is the radiation or nuclear energy that's either released during the nuclear reactions that can be controlled and which are done in the nuclear reactors peaceful uses, or that cannot be controlled in the case of nuclear bombs, such as military uses. So we can see that artificial radioactivity has two types. The first one, radiation can be controlled, for example, like this, which are done in nuclear reactors, or they are used in safe uses. The second one is radiation cannot be controlled, like these, which are done in nuclear bombs. They are used in military uses. So, scientist Dr. Ali Mustafa Musharrafa is an Egyptian theoretical physicist that he was professor of applied mathematics in the Faculty of Science at Cairo University, and he also served as its first dean. He contributed to the development of quantum theory as well as the theory of relativity, and corresponded with Albert Einstein. The peaceful uses of nuclear energy. There are many applications for nuclear energy. The first one is medical field. How come? It's used to treat and diagnose diseases like cancer. Second application in agriculture field, to eliminate pests and to improve some plant races. The third application is industrial field. It's used to convert sand to silicon sheets, which is used in electric appliances and used to discover the defects in the manufactured products. The fourth one, in electric generation field, where temperature produced from the nuclear energy is used to heat water until boiling. The water steam produced is used to operate the turbines to generate electricity. Number 5, in the space explorations field, where it is used as a nuclear fuel used by rockets that fly in space. Application number 6, in the drilling field, where it is used in the drilling for petroleum and underground water. Is the pollutant for our environment? Yeah, it is called radiation pollution. And if the amount of radiation increases, it will be pollution for our environment. So radiation pollution is the increase in the amount of radiation in the environment. Radiation pollution has many sources. The first one, natural source, like that some radioactive elements found on the Earth's surface. Also, cosmic radiation that comes from the outer space. The second source is artificial sources, such as the explosion of nuclear bombs that some countries do as experiments from time to time. Also the nuclear reactors. The radiation effect on human body. In case of large doses, it will cause bone marrow, spleen, digestive system, and central nervous system. But in case of small doses, it may be physical defects. How come? Physical defects, it means physical defects, they are changes that appear on a living organism as a result of exposure to radiation like skin cancer. But genetic defects, they are changes in the sex chromosomes composition which result in abnormal birth. The last one, cellular effect. there are changes in the cell's composition which lead to destroy the cells. For instance, if the chemical composition of hemoglobin changes, it becomes incapable of carrying oxygen. Is it clear? Okay. Measuring the radiation. What is the unit of radiation? The measuring unit is rem. So the maximum safe dose of nuclear radiation should not exceed 5 rem for a human a day. The types of radiation which produced from the nucleus, if a spontaneous decay occurs, it may be alpha particle, or gamma radiation, or beta particle. There are some means of protection from radiation pollution. The first protection: not be exposed to maximum safe doses of nuclear radiation 5 rem in one day. Number 2, the workers should wear protective gloves, clothes and masks. Number 3, the waste material of radioactive elements should be away from underground water path so it will be not polluted. Number 4, the area should be chosen correctly for waste material. It should be steady warm, not exposed to earthquake and volcanoes, and away from animals that live in caves. Number 5, nuclear waste should be put in a place which is surrounded by cement, then deep inside the earth. Number 6, place lows for nuclear stations to cool the hot water before throwing it in the seas and lakes. This is the end of the lesson. Thanks for listening. If there are any questions or comments, you can send it on WhatsApp. See you soon in the next lesson. Goodbye.